Dear students, we are starting with concept trigonometry. In trigonometry, for proving any result, we have to remember these relations. Initially, in first column, you can observe three square relations that you can remember with the help of categories. That categories are SC, ST, and OBC. OBC means we have to consider CC. So first is sin square theta plus cos square theta always equal to 1. From that first relation, we can derive two more relations. That relations are sin square theta equal to 1 minus cos square theta and cos square theta equal to 1 minus sin square theta. After that SC relation, next relation is ST. In ST, sec square theta minus tan square theta equal to 1. Here, we have to remember that negative sign is there between sec and tan. From that second relation, we can also derive two more relations. That relations are sec square theta equal to 1 plus tan square theta. If I shift that minus tan square theta on right hand side, it becomes plus tan square theta. And tan square theta equal to sec square theta minus 1. Sec square theta minus 1, that you have to remember. And third is cosec square theta minus cot square theta equal to 1. From that relation also you can derive two more relations. That relations are cosec square theta equal to 1 plus cot square theta and cot square theta equal to cosec square theta minus 1, not 1 minus cosec square theta, that you have to remember. So three main square relations for proving any result in trigo. After square relations, we have to remember three inverse relation. In inverse relation, first two are very very important. That cosec theta is reciprocal of sine. It means we can write cosec as 1 by sine and sec as 1 by cos. And third is cot theta equal to 1 by tan theta. That is not that much important. After three inverse relations, two special ratio most useful in questions of trigonometry. That first is we can write tan as sine by cos. So tan theta equal to sine by cos and cot theta equal to cos by sine. So these three types of relations where inverse and special ratios are very very important for proving any result in concept trigonometry. After this, we have to remember that basic identities, algebraic identity. That identities I am speaking: a plus b whole square equal to a square plus b square plus 2ab. Second is a minus b whole square equal to a square plus b square minus 2ab. And then after, third is most useful, a square minus b square. At that time we have to write a plus b and a minus b. Fourth one is a plus b whole bracket cube, a cube plus b cube plus 3ab in bracket a plus b. Fifth one is a minus b whole bracket cube, a cube minus b cube minus 3ab in bracket a minus b. After basic concepts, we are starting with question. So you can observe that first question is prove that cos a upon 1 plus sin a plus tan a equal to sec a. So finally we want sec a. So in questions, first preference always give to square relation if possible. Here all terms are single, it means there is no any applicable square relation. So after that first preference, second preference we have to give that sine and cos relation. It means we have to convert all ratios in sine and cos form. We can convert cosec as 1 by sine, we can convert sec as 1 by cos, the tan and cot. From that special ratios, tan equal to sine by cos and cot equal to cos by sine. So initially we are starting with left hand side, LHS. Observe that left hand side is cos a upon 1 plus sine a plus tan a. So square relation is not possible. After that, second preference we have to convert in sine and cos. So here first term already in sine and cos form. So we have to write as it is, cos a upon 1 plus sine a. Second term we can convert that second term in sine and cos form by that special ratio, first special ratio. So tan can be written as sine a by cos a. So step number 1, in left hand side we have to convert tan in sine and cos form by that special ratio. After that relation, we have to find LCM. Always use concept of LCM in fractional terms. So in LCM, just we have to do cross multiplication, cos a with cos a, cos a with cos a and 1 plus sine a with sine a. And in denominator, we have to multiply both denominators. So in denominators, we have to write as it is 1 plus sin A into cos A. One thing you have to remember that never multiply terms in denominator, write as it is. So 1 plus sin as it is and cos A as it is. In numerators, if I multiply cos A with cos A, then it gives cos square A. And 1 plus sin A with sin A, so sin A into 1, sin A, and sin A into sin A, that becomes sin square A. Now in numerator, you can observe that first square relation, cos square theta plus sin square theta, that both terms are available in numerator. So we can write sin square theta plus cos square theta equal to 1. So consider 1 plus sin A, denominator as it is. Then after next, you can observe in numerator 1 plus sin A, in denominator also 1 plus sin A. So we can cancel out that numerator and denominator, 1 plus sin A, 1 plus sin A. Same terms. After that cancellation, nothing in numerator, so we can write 1. 1 plus sin A, 1 plus sin A, cut. In numerator nothing, so finally it becomes 1. In denominator cos A is there. And initially we have used special ratio, after that we have used square relation, and at last we have to use that inverse relation. So 1 upon cos, and that gives answer sec A, and that finally we want RHS. So here you can observe 3 main steps, that tan is sin by cos, step number 1 over here. Then after step number 2, LCM. In LCM we have to do cross multiplication, cos A with cos A, cos square A, 1 plus sin A into sin A plus sin square A. We have to multiply sin A with both terms, 1 and sin A. In denominator we have to multiply both denominators, but just we have to write as it is. It means 1 plus sin as it is and cos A as it is. Then after, you can, in numerator you can observe 2 terms with squares. It means cos square plus sin square. So cos square plus sin square, that is 1 sin A as it is. After that step, 1 plus sin A, 1 plus sin A you can cancel out. In numerator nothing, so 1. In denominator cos A. And as we already know that, so 1 upon cos sec, cos is sec. That is final answer of right hand side. So here finally we can write LHS equal to RHS, it means hence proved. So from this single question you can observe that main 3 relations, square, inverse and special ratio, with the help of that all 3 relations you can solve any question of trigonometry. So basic requirements, that initial concepts, square relations, special ratios and inverse relations. Our next question is prove the following identity. It means we have to prove 1 plus cos A upon sin A plus sin A upon 1 plus cos